Hello again. In this part of the video, I will demonstrate how to set up the Arduino IDE to program the ESP8266 microcontroller. So first we need to get the Arduino IDE and install it in your computer. You can download it from its own website arduino.cc and install it. At this time of making this video, the latest one is 1.8.15, but you can install whichever version is available when you are using it or when you are watching this video. Here you can see the Arduino IDE on its first launch. On the right side, you can see the IDE, and the middle of this is the code area where you write your code, and on the top you have this very minimum number of buttons. So they are explained here on the left. The tick mark or the it does compile and verify of your code. That means when we write our C or high level code, it will be converted into machine level or hex code, which you can upload to the microcontroller using this. And if there are any errors in your code, then they will be notified here on this on the bottom, so that you can make corrections accordingly. Now this particular IDE, it supports, or you can program a large number of microcontrollers using this. Not only the Arduino series microcontroller, but in this case also our ESP8266 microcontroller. So we need to, before we can use it with our ESP8266 module, we have to configure this IDE to support our board. So for that we have to install our board support package from the board using the board manager from the IDE. So you just click select tools, then go to this boards. By default it won't be ESP8266 module, it will be your only Arduino Uno or something, and then you select board manager. Once you do that, this board manager will open. So from here you can search ESP8266 here. So as you can see, it supports this ESP8266 family. That means all these different type of microcontroller modules. So the one we'll be using is the made by Lolin Node MCU 8266. Now if there are many different versions of ESP8266 are available as well. So all these supports, they are supported by the IDE. So you can choose, you have to install this board support package first. Once you do that, then next we will test the program or test the whether the environment to programming environment has been set up properly. Now for that, let us upload, if we had uploaded the Blink program. So here you can see this this particular built-in LED is blinking with an 1 second delay. Now let us switch to the Arduino IDE to see a demo of programming the 8266 module. So here we can see this program. This is the default build program. As you can see, the program is quite easy. Now for the timing, you can ignore these. So they are basically the definition of pins of the Node MCU 8266 microcontroller. I have set up this a simple board with here you can see this is the Node MCU 8266 microcontroller which I have connected to the PC, and I have added an LDR, a light dependent resistor. That is, this resistance of this device changes if light falls on it or if the amount of light falling on it changes. And I have added two LEDs as well. So we will be blinking these two LEDs, and we will try to read in the voltage across this LDR using a program. Now going back to the IDE. So on this void setup part, you can see this part of the code, it runs every time the microcontroller is reset or the microcontroller starts. But once it has started, this microcontroller is switched to this program, the loop, so which is an infinite loop. So it will stay in this loop or keep executing this code sequentially, and until it has been reset or the power is lost. So first we define this pin as an output device. So this LED built-in, it is already defined in the library itself or the package itself. and then you write this LED built-in comma low. So once you write digital write this function, what it does, it pulls the that particular pin low, that is to ground or 0 volt. So in other microcontrollers it will be the LED built-in comma high, that means you are setting the pin to 5 volt. But this microcontroller, it has an active low state, that means when you write low, the output will be high or output will be 5 volt. That is why it's the opposite. So to turn on the LED we have to write low, and to turn off the LED we have to write high. Now once you do that, I have set up this two delays, thousandths millisecond delay, that's 1 second, and this is a 2 second delay. This is the interval in which the LED will turn on and off. Now once the program is ready, you can click on this upload button, or you can first check, verify whether the program is right or not. And here you can see on the bottom here the program being compiled. Now this is an useful information, that how much RAM is available like after using this program, and how much storage space it is using, etc. And once that is done, you can press this upload button on top, and the program will be converted into hex code and it will be transferred. So it takes a while, so you can watch the status in the bottom here. Now the program is being written. As you can see the progress of this percentage. So we'll wait till it is 100%, and then we can switch to the camera which is showing the microcontroller. Now as you can see, the program has been uploaded and the microcontroller has been reset. Now let's see the microcontroller. So as you can see, the LED has started blinking. It remains on for 1 second and remains off for 2 seconds according to our program. So you know this microcontroller or the interface, the programming environment has been properly set up. Now let's interface this LDR, a light dependent resistor, and these two LEDs to the microcontroller and see how the program works. So let me switch to the another program, that is here. Now again, these are the definitions of the pins. So for example, these two LEDs are connected to this D0 and D1 pin. So we have to initialize them as output. Then we are I also want to see the value of the LDR on my serial terminal. So I have to write the serial begin 115200 to initialize the serial port. Once that is done, we can turn on one LED. So D0, that is on, using as I have said earlier, it is an active low output microcontroller of this ESP01 device. So you have to write it in the opposite way. So digital write D1 comma high. So this second pin, the second LED is off. Now at this time you can write green LED is on and orange LED is off. So it will print this message, and then we will read the analog voltage across the LDR using this pin and this particular line, analog read A0, this function, and this voltage or the whatever we read the value, the ADC value, I want to print in the serial monitor. That's why I have put it as an argument to this particular function. Now we can delay 1000 millisecond or 1 second. Now once we after that, I am just reversing the LED state. So the D0 I am turning off and D1 I am turning on, and I can print the same thing here. And serial print ln, again I am printing this analog read A0, and this print ln is prints the value and it switches to the new line. So that's why print ln. Otherwise this way here when it prints, it won't switch to the new line. So they are both the same function but slightly different, as you can see. So it will be more clearer when you look at the actual output. Now after that, again 1 second delay, and this completes the loop. So let us upload this program to the microcontroller and see this program in action. Now it's being compiled. Okay, it's ready. Now it's uploading to the microcontroller. So you have to wait till it is complete. And the serial data we can still see in this selecting the serial monitor once it is ready. Okay. So here is the serial monitor, as you can see. This value on the right side is the ADC value, or the voltage across the LDR, and the LEDs are changing state, and in the real time here you can see the hardware. Now you can see the LEDs are blinking at 1 second interval, and this is the LDR. Now if I shine some light on the LDR, this value will change. So you can see the value here, it's 560, 560 or 600, it's approximately 600 or close to 600. Now let me turn on the light. Now let's switch to the serial monitor, and you can see the value has changed to 350 or approximately 350 or something. So now this light is a constant. Now if you increase the light's brightness, then the voltage will drop even further. So this is how an LDR works. So now that we have an working microcontroller and the sensor interfaced, the next is we will have to set up the VPS server to upload the data. But before that, I will also show the interface of the sensor that I will use for my weather station. So in the next part of the video, we will discuss the specific sensor that I am going to use for my weather station. See you in the next slide.